Welcome to Module 3.13, where we'll explore sampling approaches in quantitative research. Sampling is a critical methodological component that affects the validity and generalizability of research findings. In this module, we'll examine sampling fundamentals, probability sampling methods, and non-probability sampling approaches. Understanding these concepts will help you design rigorous studies and critically evaluate the sampling methods used in healthcare research. Effective sampling begins with clearly defining the target population, the entire group to which you want to generalize your findings. The sampling frame is the actual list or resource from which you'll select participants, which should align closely with your target population. Sample size determination involves statistical calculations based on desired precision, anticipated effect sizes, and available resources. Units of analysis must be clearly specified, whether you're studying individual patients, healthcare providers, organizational units, or geographical regions. Generalizability considerations address how well your sample represents the population and under what conditions your findings might apply. These fundamentals form the foundation for sampling decisions that directly impact the strength and applicability of research conclusions in healthcare settings. Probability sampling methods give every member of the population a known, non-zero chance of selection, strengthening statistical inference. Simple random sampling selects participants completely at random, providing the foundation for statistical theory. Stratified random sampling divides the population into subgroups before random selection, ensuring representation of key demographics or clinical characteristics. Cluster sampling randomly selects groups rather than individuals, then includes all members of selected clusters, efficient for geographically dispersed populations. Systematic sampling selects every nth member from an ordered list, creating a sample distributed throughout the population. Multi-stage sampling combines these approaches, often beginning with cluster selection, followed by sampling within clusters. These methods enhance representativeness and permit calculation of sampling error, strengthening the validity of quantitative findings. Non-probability sampling methods select participants without giving all population members a known chance of inclusion. Convenience sampling selects readily available participants. Though efficient, it risks selection bias and limited generalizability. Purposive sampling deliberately selects participants with specific characteristics essential to the research question. Quota sampling establishes categories and minimum numbers for each category, but uses non-random selection within categories. Snowball sampling relies on participant referrals to access hard-to-reach populations, particularly valuable for studying sensitive health issues. While generally considered less rigorous than probability methods, non-probability approaches are appropriate when research aims are exploratory, populations are difficult to access, or resources are limited. The key is acknowledging sampling limitations and appropriately qualifying conclusions based on the sampling method employed.